Hi, I'm Bill Wiltsey, and we're here today with Damian Josephberg from Equip, and we're talking about alignments for outages. Damian, thank you for joining us.
Thank you very much, Bill.
The first question we'd like to ask is, do you need to perform an alignment during an outage?
Well, you always want to be prepared to perform an alignment for an outage, whether it be a shaft alignment or an internal alignment, or you're going to do some other testing to change your alignment target. So you want to do certain things that you'll have as found data, so that should you choose to perform an alignment if you need to, that you'll be able to do that. But there's definitely going to be at least an alignment examination or an alignment check every time that you have an outage, whether or not you actually perform the alignment. And it's important to always have that data, so you could always go back to it. So if there is a problem, you could determine whether or not it is an alignment issue.
Okay. Leads us to our next question. What types of alignments should be performed during an outage?
Okay, well, you have different alignments for different pieces of equipment. Any rotating equipment is always going to have a rotor or a shaft, so you're always going to want to perform a shaft alignment, and that's pretty much universal that you're going to want to check that or perform a shaft alignment. When you're doing a major outage on a turbine or a compressor, or a gas turbine or a steam turbine, you're going to also want to do an internal alignment, and that's going to be where you check the internal components of that machine. Then the only other type of alignment would be possibly a foundational alignment check, to determine if you have any foundational changes or if you have any movement that you want to check to see if that's affecting your alignment position.
Okay. Is there a difference between performing an internal alignment for a gas turbine as opposed to a steam turbine?
There actually is. Gas turbine, you're always going to do a tops-on alignment, which means you're going to have the whole machine assembled with the rotor taken out in order to get all of your internal alignment readings. When you do a steam turbine alignment, you ideally would want to do an alignment with the top on, the same as you would have to on a gas turbine, but that's not necessarily always done due to different reasons. So that is a main difference between a gas turbine and a steam turbine internal alignment.
Interesting. Okay. What if an alignment is performed to an OEM target and there is vibration that is indicating misalignment?
Well, this actually happens quite a bit now, and that's because these targets are really calculated to a theoretical thermal growth position, meaning all that's being factored in is the actual growth of the material. And with newer units, they're using less and less material, and there's less and less holding all the positions into place. Also, it's the same basic frames that have been bumped up in megawatts, so there's a lot more load that exists inside of these units. So when we talk about that movement that occurs from offline to online, we're not just talking about thermal expansion of material anymore. There's a lot of torsional movement that exists. And you can do an alignment to an OEM target and then still have vibration that indicates misalignment because you're really not aligned to the actual target of the machine. So if that happens, the best next thing to do is going to be to actually measure that movement, create your alignment target from that measurement, and then align to that target that you've recorded.
In bringing up the subject of machines, what are the most common machines to perform dynamic movement studies on?
Well, the two most common traditionally are boiler feed pumps and gas turbines. This is because you have so much heat and so much torsional movement that exists in both these processes. So we do a lot of dynamic movement studies on both of these units. There's a fair amount done on steam turbines as well, but boiler feed pumps and gas turbines are by far the most popular that you would perform a dynamic movement study on, just because you're going to want to know what that machine moves, and the OEM target is always going to capture all of it, due to the fact that, you know, they do those tests when they do them on their machine, in their facility, running under their load, their piping geometry, and their environment, which is going to be different than your machine running under your load, under your piping geometry, and in your environment. So no one could ever possibly duplicate that test. So you would do that test yourself.
Okay, very good. Is there a way, as a follow-up to that, is there a way to check machine movement over long periods of time?
Well, yeah, there's given enough money and time, there's a way to do anything.
Right.
But to be more pointed to your question, another way to do it rather than monitoring online that alignment change over a period of time, because it is somewhat intensive to constantly check cabling and check that data. The other option would be to set up target benchmark points, okay, and check them over a period of time. Set these points up that that are solid fixed, so that you could see how they move over a period of time by taking snapshot data of those points. You're only going to know what the movement is for each time you take the measurement, but it's data that you'll have, and you'll be able to see it possibly under different load conditions, under different at different times of the year, and you'll be able to see how your machine moves based on those different scenarios.